In this video, we're going to find the length and the midpoint of a line segment. So over here on the right, you can see a line, and there are two coordinates, this one here and this one here, and you can see the letter D representing the distance between these 2 points. So basically Pythagoras' theorem is applied to this right angle. It's a right angle triangle. As you can see, I've joined the 2 points, the 2 coordinates up by this dotted line. Now we know that this is the second coordinate. We'll call this the second coordinate. As you can see, I've labelled it x2 and y2, and this is the first coordinate labelled x1, y1. And we can see that if we want this distance here, because remember Pythagoras is this distance squared plus this distance squared, and then obviously that will equal this distance squared. Well, if we want the distance here, we need to take away the y coordinates from each other. So y2 take away y1 will give us this distance here. Now similarly, in this direction here, we want this distance here, which will be the x coordinate here, x2, take away x1, which will give us this distance. So let's write that down. And of course, that gives us the distance squared. So now what I'm going to do to find the actual distance is to square root this whole formula. Okay, and I've placed a purple box around it. Let's do an example using this formula. So we need to find the distance between the points -1, 3 and 4, 5. So the first thing to realise is that as you're reading it, this one here is the first coordinate. So I'm going to call this x1, y1. And this is the second coordinate. I'm going to call this x2, y2. And it's simply just a case of substituting those numbers into the distance formula. So I'm going to write the distance formula out first. Done very quickly, and now I'm going to substitute those values in. So x2 we can see is 4, so 4 minus -1, which of course becomes a plus, squared, and then I'm going to do y2, which is 5 minus 3, and square that, and don't forget obviously we're going to square root that. Now let's just work that out. So 4 plus 1 is 5, 5 squared is 25, I'll put that down. And plus 5 minus 3 is 2, 2 squared is 4. And of course that will be then square rooted. So D becomes the square root of 29. So we say root 29, and that's the exact answer. But obviously if we want to round that, we'll have some decimal places. So D is approximately, according to 3 decimal places, 5.385. And obviously if there's units that are applicable to the question, put those down. But at the moment, it's just that. Now let's have a look at the midpoint of the line. Let's just have a look here. Now the midpoint of a line is basically just the halfway point along there, which is essentially the average between these 2 points. So I'm going to write down the formula for the average between these 2 points. And you can see I've worked the average out in the x direction. Remember, averages add the 2 things together, divide by 2, as you can see I've put here, and then the average of the y coordinates here, and I've placed a purple box around it. Let's do an example. Okay, so we're going to find the midpoint of the line segment joining these 2 coordinates. So the first coordinate I'm going to call x1, y1, and the second coordinate I'm going to call x2, y2. And it's just a case of averaging out the x coordinate for the first bit. So let's look at x first. So the x part of the coordinate was add the 2 coordinates together and divide by 2. So adding 5 and -3 together gives us 2, divided by 2 gives us 1. Okay, so our x is 1, and then let's look at y. Remember, y was just add the 2 y coordinates together and average those out by dividing by 2. So y is 9 plus 11 divided by 2, so that's 20 divided by 2, which is 10. So summarise our answer to say that the midpoint of the line, therefore, is the coordinate 1, 10.